Hi everyone, I'm Paul Haar. I'd like to share with you some of what I've learned as an architect from the Mullum Creek Eco Housing Project in Victoria. But before I do, I'd like to acknowledge the traditional owners of country in various parts of Australia across which we're zooming this afternoon, and to pay respect to their elders past, present and emerging. We're here where I am in South Gippsland, Victoria. It's the Boon Wurrung people that I'd like to acknowledge. The World Green Building Council has for some time put buildings as responsible for 39% of global CO2 emissions. If you add to that the biodiversity decline that's attached to both the procurement of building materials and the commandeering of previously natural ecosystems, onto which we then locate our built environments, it becomes patently clear that we as architects, building designers, engineers and energy assessors, we're key accomplices to the climate and biodiversity emergency that's before us. But that said, we can also be key drivers for environmentally and socially regenerative change. And it's why there are now thousands of Australian businesses practicing in architecture, engineering, town planning and building construction that have mobilised to declare and act on this climate and biodiversity emergency. Now, there are three main prongs to the approach that we building practitioners can take in this emergency, I think. Firstly, it's to address the operational impacts of buildings, so heating and cooling and the water, the energy that goes into running buildings through their lifetime. And this has been the predominant focus to date. Secondly, it's to address the impacts embodied in construction of buildings. And that's mainly bound up in materials. So specifying building materials responsibly has a far larger immediate impact in this climate and biodiversity emergency. And I'll explain that a bit more later. And finally, to address the amount or the scale of building that we think we need. This has the most significant impact on the first and the second prongs, but it's hardly spoken about. So I'll speak to each of these three prongs using the Mullum Creek project as a case study to illustrate many of my points. So between 2002 and 2019, so 17 years, I was heavily engaged with Mullum Creek, which is a peri-urban eco-housing development in Donvale in Victoria. It's a 56-lot housing estate under construction in one of the last pockets of residential land that's remaining undeveloped alongside the Mullum Creek, just 20 kilometres to the east of Melbourne CBD. So you can see the creek line here and the site. It's about 56 acres. It's a beautiful natural setting that was the childhood home of the project's developers, Sue, Steve and Danny Matthews. But over the past 40 years or so, this property has become virtually surrounded by peri-urban residential subdivision of possibly the least environmentally sensitive kind. The scale of many homes on minimum 4,000 square metre lots. In this neighbourhood, it's truly gobsmacking. So as you can imagine, the status quo for council and for local residents, it was severely challenged when the Matthews first applied to develop the property as an exemplar for sustainable living back in 2006. Mullum Creek has applied a range of widely accepted environmental and social principles to achieve excellent and integrated design outcomes, not only for homes individually, but also on an estate-wide basis. So almost half of the property, that with the higher natural landscape value along the Mullum Creek and in the valley that feeds into that, that's not been subdivided, as you can see here, and rather donated to the public as a nature reserve that now forms part of a larger public linear park. These reserve areas have been enriched with sensitive landscape works that extend into the residential streets through the estate. Now, Mullum Creek's taken all those obvious sustainability initiatives, like requiring for each house a minimum 7.5 star NATERS energy rating, 4 kilowatt rooftop solar power installation, a 20 kilolitre rainwater storage, and water conserving plumbing fixtures. So things you might hear of on other projects as well. But our job here was to draw positive environmental outcomes from the project that also go well beyond and address weaknesses in what was generally considered to be the best practice sustainable development at that time, so in the early noughties. Both in early project framing, in preparation of environmental design and construction guidelines that are tied contractually to the purchase of lots, as well as through formal step-by-step design reviews and construction overview, we were able to steer some 42 lot owners, 38 architects and designers, as well as 29 building and landscape contractors to a range of environmentally sensitive practices they'd not encountered before. And what we learned, we've been desperate to share widely via the Mullum Creek website, through magazine articles, particularly Sanctuary and Renew magazines, and in presentations like this one. Okay, so action prong number 1 in addressing our climate and biodiversity emergency. Certainly, the focus of the World Green Building Council until last year, and the Green Building Council of Australia, Victoria's Design Matters, and many other organisations to this day, their focus has been on improving the operational energy efficiency of buildings, so towards achieving net zero operational carbon, as that relates to thermal performance, as well as the efficiency of fixed mechanical and electrical services and loose appliances. So thermal performance is based on benchmarks for housing in Australia, as you all know, I'm sure. They've been set at by the BCA at 6 star, by Passive House at something equivalent to 7 star, by design guidelines for eco-housing estates like Currumbin Eco Village in Queensland, Beyond Today in South Australia, the Cape, on the Bass Coast in Victoria, just down the road from where I am here, Mullum Creek in Victoria, they're all at 7.5 star. And then we've got professional bodies such as BDAV's Sustainable Design Challenge, which sits at 10 star. Now, 10 star implies that virtually no energy is required to heat or cool a house throughout the year. And even a superficial review of this approach, it raises a bunch of concerns. In 2016, Swinburne Uni and sustainability consultants Pitt and Sherry, they confirmed what some of us had long feared, that the value of Australia's home energy efficiency rating system, NATERS, is, for the most, seriously eroded by lax and optimistic software data entry and by material substitutions and poor construction detailing on site. These practices reduce the thermal performance of homes as they're built, commonly by 1 to 1.5 stars below their certified rating. I've got my thoughts on how government should act to lock in more respectable thermal performance for buildings, but I won't bore you with that here. But as building professionals practicing in a climate emergency, I'd suggest that we focus on securing genuine as-built, say 7.5 or 8 star homes. We should do that by teaming up with highly competent energy assessors who we employ to consult without fear or favour through design, certification and construction phases of our projects. I think it's better that than to cajole towards a good look but low bang for buck and frankly unnecessary 10 star target. Our energy assessors also need to be paid properly for the substantial work that goes into a truly rigorous service. Now, weaknesses in the current system, they can be addressed with a few relatively simple measures that we applied at Mullum Creek. The first was to engage for the project one nominated independent energy assessor who'd apply rigorous and consistent assessment practices to guide all architects and building designers active across the estate to achieving a minimum 7.5-star energy rating for all homes. The assessor that we selected was so generous with his time, and he freely shared his extraordinary knowledge and expertise to help designers bring some thermally quite difficult schematic designs to bring them over the line. He was also always incredibly supportive to us in the Mullum Creek Design Review Committee, and I'd like to introduce you to him now. So it's Alex Wrench, and he's from Comfort Zone Energy Ratings. So it's over to you, Alex. Thank you.
Hello, Paul. Well, hello to everyone, and thanks for that introduction, Paul. I'm just going to talk about the energy rating side of the Mullum Creek project. But there's 4 key elements to Mullum Creek's approach. So as Paul said, there's a 7.5-star minimum. Now this is a sensible, sustainable and forward-looking goal, and 7.5 stars almost halves the energy requirements of a 6-star house. The use of one only energy rater, as Paul says, who's independent, competent and rigorous, I think that gives good consistency in the rating approach. The use of Accurate. So Accurate was chosen as the software to do all the house energy ratings on the estate. Accurate is the gold standard developed and maintained by CSIRO. It's the most flexible rating software around and available, especially for constructions. So for example, with colours, solar absorbance has always been able to be set exactly. With other rating software, like First Rate 5, for example, up until a couple of years ago, colours could only be set to light, medium or dark, but Accurate has always allowed solar absorbance to be set exactly. And another example is that Accurate can model 2 eaves to a single wall. Now, no other software can do this, and this is quite useful for modelling shading accurately. So it's useful when you've got a pergola and then a higher solid eave, and shading is important with these houses. Accurate is entirely data-driven, so there's no on-screen plan display. The house has to be built element by element. It's a matter of working out areas and volumes, and every part of the house has to be built in the software through the entry of data. Complex, larger designs, like some of the houses in this Mullum Creek project, can take up to 3 days for the step 1 rating, so it's very intensive. And to get to 7.5 stars can require up to 30 to 40 iterations. So it's quite an intensive process. The 4th key element is the step-by-step approach. So there's 3 rating stages, which I'll talk about in a minute. This is a really thorough and considered approach, but it can be time-consuming. So now, Paul, we'll go on to the Mullum Creek step approach. So initially, we have a step 1 stage, which is a full report on the preliminary design. So I would normally generate a detailed report with a full analysis of the house performance, and then give the required upgrade options to achieve 7.5 stars. Step 2 is at the next stage of the design, so at a more developed design stage. And so a revised rating is done. This incorporates all the design stages to that point in time with quite a bit more detailing. It may require much of the rating to be redone, and its intent is to confirm that the 7.5 stars can still be achieved. Step 3 is the final rating on the construction plans. So again, an updated rating is produced, and this is used for the building permit and for the creation of the Natur certificate. Now, this step approach, the three-step approach, is probably unique, but maybe it's the way that all ratings should be done. Many ratings now involve at least two stages where you do an initial rating, give a report, and then do a final rating. But the early involvement in the design process and then the ongoing interaction and feedback is very useful in getting a high performance house. So the key factors in achieving 7.5 stars. First, we've got the house size and shape. So in terms of size, an area of around 200 square meters or less is optimal. And people may not know, but all rating software applies an increasing penalty to houses over 200 square meters to discourage the building of very large houses with high energy consumption. Houses under 200 square meters receive a bonus. Mullum Creek houses are mostly larger than 200 square meters, and the designs can be up to 400 to 500 square meters in size. So they can be quite substantial houses. In terms of the shape, rectangular, single or double story is the most efficient design shape. Most Mullum Creek houses are architect designed with interesting but complex design features. They're often multi-story or split level and can have unusual footprints with extended wall areas due to articulation in the design. So we've had houses that have had U-shape footprints, square W footprints, even V-shape footprints. Now, all these sorts of designs lead to larger wall areas, and larger wall areas relative to the floor area increase the potential for heat loss and heat gain. And that all makes it harder to get to 7.5 stars. The second key factor is orientation. So ideally, living areas and bedrooms should face north with services to the south. But in reality, other factors like views and access and topography may override the best thermal performance considerations. But careful and considered design can compensate for some of these issues. The Mullum Creek Design Guide provides extensive design advice on orientation and passive solar design. Glazing is a really key part of the house design, especially when getting to 7.5 stars. And Mullum Creek houses have large glazing areas. When the ratio of the window area to the conditioned floor area exceeds 30% for houses with concrete slab on ground floors, double glazing and other measures are going to be required, especially for 7.5 stars. And high performance windows are going to be essential to reach 7.5 stars. It's interesting that windows are the weakest point in the overall house envelope. So even with high performance double glazing, the insulation value is only about R0.3 to R0.5. So the R value is the inverse of the U value. So a U value of 3 will give you only an R value of 0.3, 1/3, and a U value of 2 will give you an R value of 0.5, so that's a half. So that's really not much more than an uninsulated timber-clad stud wall. So windows are indeed the weak point of the house envelope. Now the wall, ceiling and roof insulation, in these houses, we require high levels to get to 7.5 stars, but there's diminishing returns. So once you get above perhaps R5 for ceilings, and R2.7 for walls, there's only incremental gains on performance. Something like a roof blanket, though, can add 0.1 stars to the rating. Now, slab insulation is the one thing in the Mullum Creek houses that has the greatest impact of any upgrade measure. So this typically adds between 0.4 to 0.8 stars. And this is using R2.0 to R2.5 rigid insulation under the slab like XPS, extruded polystyrene. The slab insulation that we're talking about is not waffle pod insulation. So within the rating software, there's algorithms that handle the insulation value of waffle pods. But with slab on ground, where we put in insulation underneath, we have to use a rigid insulation like extruded polystyrene. But the big issue here is that all rating software assumes that under slab insulation is continuous. Raft type slabs have got stiffening and reinforcing beams that are not normally insulated. And so under slab insulation is typically only installed to the flat underside areas of the slab. In practice, this means that as much as 30% or more of the slab is not insulated. This can have a serious impact on the rating, and we've tested this, so in fact it can be 0.3 to 0.5 stars lower. The Mullum Creek Ground Slab Insulation Guide was written to provide advice and suggested alternatives because of this. Thermal mass is beneficial for difficult houses, and it can add 0.2 to 0.4 stars to the rating. Thermal mass acts as a heat sink and helps to moderate internal temperatures by reducing temperature extremes. So we can use options like bare concrete floors, reverse brick veneer walls, internal masonry. These things all add internal thermal mass and they can benefit the rating. So bare concrete floors in particular, because the concrete floor is substantial. If we have floor coverings, that restricts access to the mass of the floor. So often these houses can have bare concrete floors in the living areas or even in the bedrooms. It's a design feature and some people have chosen to go that way. Colours, external walls, roofs, doors and window frames all affect the rating, and they have to be modelled accurately under NATER's rules. So for example, we can model the window frame colour, and dark window frames can add 0.1 stars in the cool Victorian climate. Reflective wall wrap. Due to condensation issues in colder climates, vapour permeable or breathable wall wrap is now commonly used. But this is usually non-reflective, but reflective breathable wall wrap is available, and this can add 0.1 stars. So this is another option for getting up to that 7.5 star mark. Ventilation and shading are important, and they're beneficial for highly glazed rooms with excessive solar gain, as exemplified in this classic passive solar design diagram on screen. Horizontal shading works best for north-facing windows, and for west-facing windows, vertical shading can be best. Vertical shading often works best when it's adjustable, so blocking summer sun but allowing winter sun in. And so the example there is awnings or things like external Venetians. So that's all from me, Paul.
Thank you heaps, Alex. That's awesome. So at Mullum Creek, once construction was underway on home sites, we provided owners with a free inspection service to ensure that the thermal performance that was designed into a home was carried through to the final constructed outcome. Both energy assessments and construction overview were generously funded by the developer family. As Alex mentioned, constructing an on-ground concrete floor with continuous under-slab insulation, so to provide both good uninterrupted thermal resistance and internally accessible thermal mass, it's really challenging, it's potentially expensive, and it's a practice that's generally unfamiliar to the Australian home building industry. Mullum Creek designers and engineers were most able to wrap their heads around continuous ground floor insulation when they were insulating over the structural slab with minimum R2 XPS insulation, as Alex mentioned, and then pouring another concrete screed over that if the client was after a honed concrete floor finish. Or alternatively, they could lay timber strip flooring over a batten cavity and that batten cavity was insulated with minimum R2 high density polyester or earth-wool batts. But the thermal mass of the floor of the concrete structural slab would be largely lost in that process because it wouldn't be available to the interior of the building. But that concrete screed over structural slab option, that's really quite expensive to construct, and it's wasteful of concrete and reinforcing steel. So we advanced some leaner solutions through our ground slab insulation guide that you'll find on the Mullum Creek website. It includes construction details that are being successfully implemented on the estate. If regulatory bodies want to raise the thermal performance of new homes in cool climates, much beyond the currently mandated 6 stars, I think they'll need to first include in the NCC, the National Construction Code, new practical default design solutions for continuously insulated ground slabs so that they can support this raising of the bar. Now, Mullum Creek recognises that, certainly in southern parts of Australia, high home energy ratings and rooftop solar power systems, they're crucially reliant on good access to low winter sunlight between residential lots. To that end, we modelled and prescribed 3D building and vegetation envelopes that were necessarily specific to each lot on this hilly estate, and inside which all construction and new planted trees needed to be contained. Unlike standards that apply via planning codes and overlays to other housing developments in cooler climate zones of Australia, these Mullum Creek envelopes preserve full interlot solar access for each home, even in the depths of winter. We simply placed dwelling forms as they were submitted to us for design review into their prescribed envelopes on the terrain of our 3D CAD master file. And you can see the building envelope sort of ghosted or translucent over those. It was then easy to identify where dwelling forms would encroach their envelopes. You can see a few encroachments here, and they might even risk overshadowing neighbouring homes. An evolving estate master model that was posted and regularly updated on the project website that provided everyone, lot owners and their architects, neighbours and council, web surfers, and of course, us as the Design Review Committee, provided an up-to-date virtual estate navigator tool for exploring view lines, shadow lines, and how all homes on the estate were emerging well ahead of construction commencing. Okay, so what about building materials, our action prong 2 in addressing the climate and biodiversity emergency before us? A report was tabled at the World Economic Forum in Davos in 2018 that put the world's consumption of materials at above 100 billion tonnes a year. And that's quadrupled since 1970, whilst population around the planet in that period only doubled. Between 2016 and 2018, so just 2 years, this consumption had jumped by more than 8%, yet the reuse of materials had fallen from 9.1% to 8.6%. The CEO of Circle Economy, Harald Fiedel, who tabled the report, had this to say: "We risk global disaster if we continue to treat the world's resources as if they were limitless." Now, a lion's share of these consumed materials, nearly 40%, it's turned into houses alone. The World Green Building Council also tells us that of all global carbon emissions attributable to the built environment, 28% are embodied mainly in the procurement of materials. There are no clear figures for Australia, but from e-tool outputs and the work of Andre Stefan and Robert Crawford at Melbourne Uni, I'd like to suggest that the ratio between embodied carbon and operational carbon in Australian building stock is actually much higher than the global average. And that's because the floor area attributable to each occupant in our homes and workplaces, as well as the volume of vacant buildings in our cities and at our holiday destinations, they're higher than almost anywhere in the world. You can note from this infographic from Stefan and Crawford that as building size per occupant increases, operational energy use increases at a lower rate comparatively, as you'd expect. We have a relatively benign climate as well, and that moderates heating and cooling loads compared to many other countries. And our newer habitable building stock generally has got better thermal performance and appliance efficiency, and it's also better maintained than that in much of the developing world, where construction has charged forward to lower performance standards and at a blistering rate. Per square metre of floor area, it's fair to say that the operational energy and water efficiency of new housing in Australia is slowly improving. What this means, though, is that the materials used to construct buildings remain as the primary driver to the overall life cycle environmental impact of a home. So building services and appliances attached to the operation of homes can be upgraded to embrace new technologies and to provide improved energy and water efficiencies through what needs to be a long service life for a home. You can see here, just say that, what accurate or thermal performance assessment captures. It's really just this part of this bar graph of total life cycle environmental impacts of a typical 6-star home. And that is reduced significantly to 7.5 star, but you can see here that the overall life cycle environmental impact, which is really what we need to really be looking at, is not really changed all that much. Certainly, including solar power has a sort of a compensating effect that is significant. Certainly, as you get high up in your kilowatt, the kilowatts in your installation. But our specification of concrete, steel, bricks, and wood, it's got much more serious environmental impacts, and they are almost immediate, and for the most part, they're locked in, less so for us and more so for future generations to face by way of resource depletion, biodiversity loss, and climate change. So if you have a new building in design on your desk, its overall environmental impact across the next 10 years, so this period of emergency, like none we've faced before, it'll be tied almost entirely to its construction. If you believe the science as it's presented to us, what matters most now is how deeply and quickly we arrest CO2 emissions and biodiversity collapse. If we don't move mountains in the next 5 to 10 years, our future on this planet will be bleak. We have an acute and an urgent responsibility to future generations to design buildings that are of modest scale and flexible. Now, there are, of course, tools available to measure and verify life cycle environmental impacts. So embodied and operational impacts such as carbon emissions, water use, toxicity, ecosystem degradation from cradle to grave. There might even be some terrific ones out there. There are, but those that I've engaged with can tend to draw on inflexible assumptions about the future. They can produce quite different outputs from the same data entry, and they can result in reports of only limited benefit considering the time and the money that goes into them. So certainly we can avail ourselves to these tools, and I suspect they will get smarter over time. But in the meantime, in this climate and biodiversity emergency, we've got to respond to the simple truth, and that's that cement and concrete products, steel, fired clay products, timber, and swimming pools are currently the most impacting materials to be locked into our homes as they rise from the ground. So a couple of thumbnail sums and a good dose of critical and future thinking, they go a long way in guiding our material specifications towards environmental and social responsibility. For Mullum Creek, we prepared a series of materials info sheets that attach to the estate's design guidelines and direct lot owners and designers and builders to materials with relatively low environmental impact. We did that either by formal requirement, in the case of timber, cement and concrete, or we did it by informal recommendation with steel and clay products, for example. And these guides and info sheets, they're all freely available on the Mullum Creek website, and I encourage you to have a good look through there if you can. Let's start with cement and concrete. The World Green Building Council, it tells us that the manufacture of Portland cement for concrete accounts for a whopping 8% of the planet's greenhouse gas emissions. So roughly the same globally as the entire transport sector. But there are alternative, equally effective and readily available concrete binders, such as fly ash, which is a waste from coal-fired power generation, and slag, which is a byproduct from steel smelting. And these alternative binders are collectively referred to as supplementary cementitious materials, or SCMs. Across the Mullum Creek estate, it's required that a minimum 30% of Portland cement used in concrete, mortar and rammed earth walling, that it be substituted with SCMs. These alternatives for wet mix concrete, as well as for bagged cement, are now readily available at most batching plants and hardware stores, certainly across our major cities. Last year I was on the phone with a bright young architect, Rodrigo Roca. He recalled someone, I think it was from Austria, telling him that rammed earth in Australia is not rammed earth, but rather dirty concrete. And he was right. There's certainly nothing environmentally responsible about building a 350mm thick rammed earth wall containing 10% Portland cement by volume. The wet mix for casting a 190 thick hollow concrete block contains only 14% Portland cement. There's a lot less volume in material there. For earthwall construction and soil stabilisation, the use of binders like Australian Builders Steel Pave, being 85% white slag, it also avoids the need for Portland cement. Slag performs just as well as a cementitious material without reducing those nice earthy wall colours to a drab grey, which Portland cement does. When I was a young bloke, we built a lot with rammed earth and puddled mud. We put effort into selecting and blending aggregate with the right gradation of particle size and colloidal content to achieve good strength and weatherability without the need for cement. We followed the CSIRO National Building Technology Centre's Bulletin 5 on earthwall construction, and we did the old-fashioned thing of erecting test panels before proceeding with each build. The Mullum Creek design guidelines require that SCM make up a minimum 30% of the cement used in wet mix structural concrete, and some architects and builders have chosen to increase that to up to around 60% where surface finish is not so critical. As construction commenced on the estate, we found that more and more local batching plants were supplying concrete with SCMs with no increase to supply cost. In time, it should actually be considerably cheaper because slag and fly ash are problematic industrial wastes that are otherwise expensive to dispose of. Initial resistance to SCMs had subsided on site as concreters found ground slabs containing SCMs were actually stronger with less shrinkage cracking, and as shotcrete sprayers learnt not to add water so liberally to adjust the workability of the SCM mix they had on site. And as bricklayers and rammed earth wall contractors, they realised that bagged cement containing 50% SCM, so that Australian Builders Eco Blend, but that product was equivalent to general purpose Portland cement in both performance and price. So to massively reduce carbon footprint embedded in your builds with a no-cost, no-brainer, I'd strongly encourage you to specify concrete and cement with SCMs in lieu of Portland cement. And you can refer to the Mullum Concrete and Cement Products Guide to make it a complete cinch. These days, we're going further and further afield to source virgin rock and sand for concrete. The sand can't be weathered and rounded in the way beach and desert sands are. It needs to be angular to create a good structural matrix. And so it's surface mined from recent sedimentary deposits that lie beneath often delicate natural landscapes. Globally, it's acknowledged that we're about to simply run out of virgin angular sand. And so R&D for recycling our gigantic hard waste streams to produce both coarse and fine aggregate for concrete, that needs to ramp up urgently. And as it does, we building professionals, we need to promptly preference these recycled products via our concrete specifications. So by referring to the Mullum Creek Concrete and Cement Products Guide, you can find out who batches concrete with SCMs. ACM Ecrete and Wagner's EFC, they contain geopolymers that activate SCMs to avoid the use of Portland cement altogether. And a number of the suppliers listed also blend crushed concrete in with the aggregate mix, certainly for lower MPA mixes, and they can source coarse aggregate crushed from rock that's removed from excavations on construction sites. All these initiatives lower the embodied carbon and biodiversity impacts of wet mix concrete significantly. Now, fired clay bricks are back in vogue. Austral Bricks have a small brick making plant at Longford in Tasmania that uses mostly sawdust from local sawmills to fire its kilns. To my knowledge, apart from the few bricks that are produced there, it's a small plant, we're looking across Australia at around 660 megajoules of gas to produce solid fired clay bricks for 1 square metre of single skin brickwork. For the same 1 square metre of 90 millimetre thick solid concrete blockwork, it's only 240 megajoules. So in this emergency, until we can decarbonise the bulk of this very energy intensive industry that produces fired clay bricks, we need to use recycled bricks or other wall cladding materials where we can. And we might look once again to sun-baked mud bricks. They're actually not in vogue at the moment, but with good QA in manufacture and climate conscious architectural detailing, sun-baked mud bricks can be laid as tall and as weather resistant as rammed earth and as other masonry and monolithic wall systems. We could easily refine this very simple, environmentally benign and socially inclusive construction method for a 21st century revival. These photos are from one of several community self-build projects that had me living and working up north through the 1980s and early 90s. What about steel? We're told that the manufacture of steel accounts for another crazy 8% of the planet's greenhouse gas emissions. I think there's nothing wrong with a sheet of corrugated iron. Coated steel wall and roof cladding, it provides an expanse of robust and almost maintenance-free cover that's difficult to surpass at less than 0.5 millimetre of material thickness. But per unit volume, the carbon footprint of steel is staggeringly high compared to all other common building materials, including aluminium. You can see here how 9 millimetre thick fibre cement sheet that normally contains around 40% plantation wood fibre, it's got an embodied energy significantly below that of only 0.5 thick coated steel sheet. And check out the embodied energy of just 2 sheets of light SL82 steel reinforcing mesh in a 120mm thick concrete slab on ground. It's about the same as the embodied energy in the concrete itself. So here it's 20 MPa concrete with only Portland cement as its binder. When 40% of Portland cement is substituted with SCM, the light steel reinforcement ends up having the more dominant carbon footprint. So in volumetric measure, you can see here the extraordinary carbon footprint of virgin steel that's smelted from iron ore with heat from coal, certainly in Australia. Reducing the amount of weighty steel in construction is one of the best ways to minimise embodied carbon. In too many simple structures, I see steel used where substitution with a responsibly sourced timber would have been a cost-saving no-brainer. On some building sites, it's almost obscene. So the Mullum Creek design guidelines, they were formalised with a requirement prohibiting the use of cold-formed steel framing, but the use of hot-rolled steel, it wasn't permitted. I learned a few years later that the Currumbin Eco Village in Queensland prohibited hot-rolled steel without undue resistance from designers and builders. So in retrospect, I reckon we could have done this too. Nonetheless, the Mullum Creek Steel Products Guide lists steel products that are manufactured locally via comparatively energy efficient ISO accredited processes. Look, we need to start questioning architecture on our drawing boards that relies on highly reinforced concrete and hot rolled steel to stand up. We need to ask ourselves, why such structurally demanding designs are necessary? Are we chasing building heights that are simply unsustainable? Also by social measure? And has our architectural flair for gravity-defying cantilevers, has that overtaken our responsibility to design light and lean in response to the emergency that we've got? What other less impacting materials could we use for these structures? You'll read it everywhere. Wood is good. Wood, the ultimate renewable, responsible wood, make it wood. Well, contrary to popular belief and some heavy marketing, timber can be the very best or the very worst material you'll work with as a builder, depending on where and how it's sourced. If it's sourced sensitively, it can store carbon through and beyond its service life in construction. It can be reused and recycled, or it can be harvested from deliberately planted and sensitively managed forest, helping to maintain healthy ecological processes, sequestering atmospheric carbon and contributing to the social and economic well-being of rural communities. But if it's harvested insensitively, it can result in serious and irreversible impacts on flora and fauna, on soil health and waterways, and it can reduce or even reverse a forest system's sequestration of atmospheric carbon, and it can erode the well-being of rural and Indigenous communities. Even before our Black Summer commenced in September 2019, deforestation was responsible for 17% of global greenhouse gas emissions. Just the current rate of deforestation of Northern Hemisphere boreal forests, so that's the band you can see through the Northern Hemisphere up the top here, through Canada, Europe, Eastern Europe, and Russia, and into Siberia. It's the largest terrestrial biome on the planet, and that continued deforestation will have catastrophic impact on our global climate if it continues at anything like its current pace. Over the past few years, our Bunnings stores have transitioned their sourcing of softwood framing timber away from fast-grown radiata pine, so from temperate climate Australian or New Zealand plantations, and towards slow-grown Baltic pine or spruce. Now, much of that imported softwood is from those boreal forests, so intact, mixed broadleaf and conifer forests of Russia and Eastern Europe. Really beautiful environments. But what you can do, because no one will show you it when you go to the Bunnings store, and many people are not even aware, just check out the end grain. If it's tight and close, like on the bottom right-hand side of this slide, you'll see that there might be 30 or 40 years of growth, each growth ring indicating a year of growth. That's a very slow growing. It's come from the other side of the planet, from these boreal forests. Top left-hand side, you can see fast-grown, temperate climate, Australian radiata pine. You can see how quickly it's grown. The exact same size of a piece of wood, maybe between 5 and 10 years of growth in that timber section. So that's the good one to go for. And in Australia, it's our tall and relatively intact sclerophyll forests from which the durable, stable and attractive native hardwoods for architectural applications are usually extracted. But cyclical clear felling of tall, wet sclerophyll forests in often mountainous terrain, that depletes biodiversity and other ecosystem services. It encourages a regrowth that's thick with ladder fuels and causes exposure-related dieback of the often lone habitat trees left standing. And that then exacerbates wildfire risk. These damaging impacts are now compounded by a hotter and drier climate. Just over a year ago, our country's slowly raising environmental concern saw at least a good proportion of Victoria's remnant native forest protected from logging. Conveniently, though, at these times, we turn again to the tropical rainforests of poor Southeast Asian and Amazonian countries. We go there for our Coomera decks and our Merbau window joinery. The unprecedented Australian forest fires of 2019 and 20, they've highlighted the palpable reality and the inertia in our global climate and biodiversity emergency. A movement of community concern has emerged in response, and its inertia is shaping up to be equally palpable. So there's a rapidly increasing mindfulness that the preservation of biodiverse natural forests, it's got to be core to our emergency action, to caring for country. And seeing our native forests stressed by heat and drought like never before, specifiers and purchasers of timber products are now questioning the cross-generational ethics and the common sense in continued forest logging. Mullum Creek, it requires that timbers used on the estate be sourced in accordance with quite stringent environmental and social criteria. Essentially, that they be either on our approved timber products list, that they be FSC certified and from Australia or New Zealand, so not PFC, but FSC, or that they be recycled from a prior constructional use. And that leaves many good timber choices across all architectural and engineering applications. And it sends a strong message to the now global timber industry that will entertain only wood that's sourced with true environmental and social responsibility. So we've compiled background papers and a comprehensive list of readily available timber products that are suited to all applications and budgets. And these are regularly updated, so check them out on the website. We were really pleased and a little bit surprised how designers and particularly builders at Mullum Creek embraced with minimal resistance timber products we required them to choose from. And we know they're now carrying this new product awareness to their other jobs. Site and waste management, there's a terrific guide that my colleague Rafi prepared on site and waste management to reduce that, the waste that goes to landfill by 80% at the least. There are do-it-yourself options and outsourcing options to achieving those objectives. And just really quickly, action prong 3 in Address of the Emergency, I've touched on it earlier. There is nothing sustainable about an 8-star 400 square metre home. So we were in the last 20 years, we've actually gone from 50 square metres to 87 square metres per person. That's what we feel we need to live in Australia on average, each person. And how do we compare with other countries? So the bar graph at the top speaks for itself. And the same supersize it trend also applies to office and retail buildings. It's not just about housing. So we live in an age of enlightened greed. And this was, for me, the only and really disappointing part about Mullum Creek project was its failure to cap the scale of homes built adequately. We put things in place to a degree to do that, things like these prescribed building envelopes and limits to site coverage attached to the contract of sale. But there are some monster homes on the estate, as Alex pointed out as well. But putting that concern about building scale aside, the Mullum Creek project, it certainly serves as an exemplar for site-sensitive building and landscape design. It showcases energy-efficient architecture, and it'll promote the use of environmentally responsible building materials. So things that you'll see in place on the estate. And this is a home that won last year's Design Matters National Award. It's at Mullum Creek, a beautiful home. It's not one of the monsters. So there's plenty of scope for architectural expression with a lot of this strictness about thermal performance and material selection. There's still lots of beautiful things you can do. And another terrific legacy of the project will be in the advancement of people. So lot owners, designers, engineers and builders who've been able to engage in the project. We were also able to publish a swag of practical guides and info sheets that I've touched on to support the implementation of these environmental initiatives. And those guides are now circulating widely, also beyond this state, as free knowledge for the commons, and you can find them on the project website at Mullum Creek. So yeah, thanks everyone for joining in on this webinar. Thank you.